All right, in this lesson, we're going to be looking at the probability of mutually exclusive events. Two events are mutually exclusive if they both cannot happen at the same time. For example, whenever you toss a coin and that one coin flip, you cannot get heads and tails on that same coin flip. So those are mutually exclusive outcomes. All right, so the probability of A or B occurring is the probability of A plus the probability of B minus the probability of A and B. That is the formula that we use whenever two events are not mutually exclusive. If two events are mutually exclusive, then the probability of A and B occurring would be 0. Going back to that coin flip example, the probability of flipping a coin one time and it being heads and tails, it's 0. It's impossible. So the probability of A and B in that mutually exclusive event would be 0. All right, so example 1, we're trying to find the probability, we're trying to determine if these are mutually exclusive. So if they are mutually exclusive, then the probability of A or B will be the probability of A plus B if they are mutually exclusive. So we'll plug in the values that are given. Probability of A or B, we're told, is 13 over 20. Probability of A is 1/5, and the probability of B is 9/20. So we need to get a common denominator. All right, so 1/5 we can rewrite as 4/20. 4/20 plus 9/20 is 13/20. Since the probability of A or B is the same as the probability of A plus B, then we know that these are not these are mutually exclusive events. And then now we are told that A and B are mutually exclusive. So since they are mutually exclusive, then the probability of A or B will equal the sum of those two probabilities. So plug in the probabilities that are given. A or B is 4 over 5. Probability of B is 1/4. So we're going to subtract 1/4 from both sides. Get a common denominator. 16 over 20 minus 5 over 20 is 11 over 20. And next example, we're given several probabilities. We're trying to find the probability of A or B occurring. Now, if you take a look at this problem, we see that the probability of not B is 3/5. So the probability of B is the first thing that we need to find. So if we subtract 3/5 from 1, we get 2/5. And if I add 3/5 and 2/5, I get 5/5. If I multiply 3/5 times 2/5, then I get 6/25. Again, the probability of A is 3/5. Probability of B is 2/5. When I multiply 3/5 times 3/5 times 2/5, I get 6/25, which equals the probability of A and B. A and B is 6 over 25. All right, so I know that those two events are independent of each other. So I'm just going to plug in the probability of A or B occurring is the probability of A plus the probability of B minus the probability of A and B. So 3/5 plus 2/5 is 5/5 or 1. 1 minus 6/25 is 19/25. And the last example says a litter of kittens consists of 2 gray females, 1 gray male, one black female and 2 black males. You randomly pick one that is gray or male. All right, so these are not mutually exclusive because there are cats that are both gray and male.